Let's summarize what we've learned about transformations in section 3.5. We'll do this using the parent function of the cube function, f of x equals x cubed, and then we'll draw some conclusions and look at an example. So what's important to point out are the transformations taking place outside the function versus those taking place inside the function. By that I mean, here's our parent function. We are going to raise to the third power before we add, whereas in this example, we're going to add before we raise to the third power. So that plus 3 is happening inside the function, here outside the function. Anything happening outside the function causes a vertical transformation. Any change in vertical affects the y coordinates of the points. You have your original points plotted for the cube function, and they're going to move based on these different transformations we can do. And if it is outside the function, like these 4 examples show, then that will affect your y coordinate of your points only. Y is the vertical axis. For all the transformations that take place inside, multiply by 2 before you cube, as opposed to after. That will be inside. That has a horizontal effect. It affects the x coordinates because the x-axis is the horizontal axis. Okay, so we're going to just make some notes here about what would happen for this one. And of course, when we see this outside the function, that means it's a vertical. Vertical what? It's a vertical shift up 3, right? Vertical shift up 3. This would be a horizontal shift because it's inside the function. Which direction? This is the tricky one. It says plus 3, that means to the left. Okay? And the next one, we're going to raise to the third power, then apply the transformation of a factor of 2. So we know it's on the outside, so it's vertical. And what happens here? Well, when you take every y value and multiply it by 2, you're stretching the function vertically. So it's a vertical stretch. Okay, I'm just going to make a little note here. What we would do, here we would add 3 to every y coordinate. Here we would multiply by 2 every y coordinate. So we can put times 2. Okay, here it's inside. We're going to multiply before we raise to the third power. So it's a horizontal, but is it a stretch or a compression? This would be a compression, a horizontal compression. And this would be for the x values, right? These are the x values that are affected, and these are the y values that are affected. And how are they affected? Add 3, multiply by 2. This one would be multiplied by 2. Okay, now we have 1/2 times. This is a vertical compression. So you would multiply by 1/2 all the y values. You have your ordered pairs. Oh, that's what you would do for this. Okay, now we're going to multiply by 1/2 before we raise to the third power. This is a horizontal stretch. So we multiply by 1/2. Now thinking about why do they sort of switch places based on the numbers? Well, if you think about horizontal direction and you want to compress it, that means you're taking your branches, for example, if it was a parabola, and you want to compress it horizontally, right? So compressing horizontally is going to pull it in tighter, right? And stretching it horizontally would then pull it out, which is the opposite of what this is doing. Okay, raise to the third power, then apply the negative sign. What's that going to do? Well, this is a vertical. It's all vertical because it's all outside the function. It's a vertical reflection. Now, if you reflect vertically, which axis are you flipping over? The x-axis, right? But does that change the x values or the y values? X is staying the same. If you go out to 3 on the number line and you're above it, and then you flip over it, you're still at 3. It's the y values. So what you end up doing is you multiply each y value times -1. Okay? So this is multiplication. Whoops, I don't want to put that there. Times -1. This is what you would do. This would be +3 to your y values. All right? And then here, if you change the sign and then raise it to the power, you have a horizontal reflection. Put that there. Okay? For each x, you multiply times -1. Okay? Horizontal reflection. What does that mean? If it reflects this way, it's over the y-axis. So you may want to, if you want to, write over x-axis. But when you go over the x-axis, the x's aren't changing. The y's are changing. When you go over the y-axis, the y values are not changing. It's the x's that are changing. Okay, so the key is looking at inside versus outside. Outside is vertical, inside is horizontal. Vertical means y values, horizontal means x values. That's what all this says. Just a reminder, if you're adding and subtracting, you're having shifts. If you're multiplying, you get your stretches and compressions. If there's a negation, you get a flip, or another word, reflection. A summary here about the stretches and compressions for vertical. If you have a number bigger than 1, it's a stretch. And between 0 and 1, it's a compression, and then it flips for horizontal. Now let's look at an example. We want to talk about what transformations are taking place. This is the original parent, would be f of x equals x cubed, and all these transformations are taking place. So what transformations do we see? Well, that negative right there means it's outside the function, right? We only have one thing happening inside the function. That's it. So we have a negation outside the function. We have a multiplication outside the function. We have a shift outside the function. And then we have a shift inside the function. So the negation means that we will have a vertical reflection, which is a flip over the x-axis. And if we had a set of ordered pairs and we wanted to, from here, and we want to change them to this graph, that would mean we would multiply y by -1. All the y values would change sign. That's one of our transformations. The next one is a vertical. It's outside the function, so I know it's vertical. And it's a stretch because it's a number greater than 1. S-T-R-E-T-C-H. It's a stretch, and we would multiply y by 2. Every y coordinate would get multiplied by 2. Number 3. Now we're inside, so we have a horizontal shift. It's x plus 3, so what would we do? We would subtract 3 from x. We're going to the left. Plus 3 means left 3. And number 4, we have a vertical, because we're back outside the function, shift, and it's down 4, so we would subtract 4 from y. Okay.